All right, y'all. Today or this time, I don't know if it's the same day you're watching these videos, but it is the same day that I'm making all of these videos. So right now we're going to factor a difference of squares. And what a difference of squares looks like is I've got something squared minus something squared. If I see this scenario happening, then I can factor this by opening up two sets of parentheses and dropping a plus and a minus respectively. Now you can start with the negative if you wanted, but again, I always just start with a plus first and then put my minus in there if my signs are different. Then to factor this, what I put in the first spots of my two parentheses is just whatever the square root of this first term is. So the square root of x squared is x. And then same thing with the second spot in my parentheses. It's going to be the square root of that y squared is what I'm going to put in each one of those places. And I'm done factoring that. Now, if you see something such as this, x squared plus y squared, you cannot factor a sum of squares. So if you see this scenario here, just know that this is prime. Don't waste your time on it. So jumping into a couple of examples here. Looking at this first one, x squared minus 25. Now, a lot of times, or sometimes, it makes it a little bit easier if you rewrite your polynomial as something squared minus something squared. So 25 is the same thing as 5 squared. So that way, when you jump down into your two sets of parentheses, bringing your plus and your minus, then you bring one of your x's, and then one of your fives, and you're done. I'll do one more just because. X squared minus 81. Write it as something squared minus something squared. And then bring down your two sets of parentheses. Put a plus and minus down there. Put one of them here. Put one of them here. And then one of those here. And then one of those here. And you're done. Oops. I got a little happy on my eraser. Now, they're not always going to be that nice and pretty, which is the case of number 6. And this is why it's problems like these, which is why I say it's nice to write it as something squared minus something squared. Because right now what we see is 9x squared minus 16. But what you need to understand is 9x squared is the same thing as 3 squared x squared. And then using our properties of exponents, we can write this as 3x all squared. And so when I write this as something squared minus something squared, I can jump down to my two sets of parentheses, got my plus and my minus, and I can take one of my somethings and put it here, and then take the other something and put it down here. And then my 4s, I take one of them, put it here, and take the other and put it down here. Now let's just say that's still a little too messy for you. There is another way that you could go about factoring this, and it is using substitution, which substitution is super nice to use because it's a way that you're able to get your factoring done with real pretty numbers or letters, variables, and then you go back and put stuff in. So I'm going to do this one that way. So when I have what I would consider a messy something squared, I'm going to say, all right, well, let's let I'm going to use another variable. Just don't use the same variable as what's in your polynomial. So I'm going to say let u be 3x. So what I'm really working with is u squared minus 4 squared. And this is something I'm pretty comfortable with factoring. So I'm going to bring down my two sets of parentheses, my plus and minus, and then one of those u's, oh, and then one of my 4's. Now I'm not done because I have to write my finished product in terms of the same variable as what we started out with. So I said that u is 3x. And so wherever I have a u, I'm just going to go plug in my 3x. And I'm done now. Let's do another example where I'm going to do it both ways. I'm going to do number 9, where I'm going to do the way without any substitution, and then side by side, I'll do it with substitution. So what I've got is 144x squared is the same thing as 12x squared. And 169 is the same thing as 13 squared. So I'm going to open up my two sets of parentheses, bring down my plus and my minus, put one of those somethings here, put the other something there, and then bring down a 13, bring down a 13, and we're done. But using our substitution, we don't like dealing with that whole messy something squared. I'm going to say, well, let's let u equal 12x. So what we're working with is u squared minus 13. And then I factor that as u plus 13, u minus 13, and then go back and put that 12x wherever we have the u. And we're done with that one. Alrighty, moving right along to another example here. Looking at number 18, I want to see if I can factor this. So I don't have perfect squares, perfect square, and I definitely don't have a minus. So I know that I'm not going to be able to use my difference of squares, but always be looking for that greatest common factor. And here I've got 50 and I got 8. I know at least 2 is a common factor. And so I'm going to start out with that. Let's say I want to be lazy, and all right, I'm going to start out with a 2 because both of my numbers are even. So I'm going to factor a 2 out of there. 50x squared divided by 2 gives me 25x squared. Then I bring my plus over. 8 divided by 2 is 4. And then I'll look at, okay, well, 25 and 4, they don't have anything in common. So I was good with my greatest common factor of 2. And then I say, okay, well, that's a perfect square. That's a perfect square. But this is not a difference of squares, so I can't factor anymore. This is as far as it goes. So I'm done with that one. Let's move over to 17. Let's back it up just a minute. Looking at 8 and 18, both of them are even. So I'm going to see how far I get with a greatest common factor of 2. And so when I factor that 2 out, what do I have left? 18x squared divided by 2 is 9x squared. Negative 8 divided by 2 is negative 4. And so I got myself to a point where I have perfect square, or both of my terms, they don't have a common factor. So I was good with my 2. Then I say, okay, well, I have a perfect square, and a difference. So I can factor this difference of squares. Don't forget to bring down that 2. And so in this case, I've got 9x squared, and you can write it as 3x squared minus 2 squared. And then when we factor this, plus minus, bring down one of those somethings, bring down the other something, and then bring down one of those 2's, bring down the other 2, and we're done. I hope that helped with factoring a difference of squares. Y'all take it easy.